Then what is the meaning of saying these things? Huh? FPIC. FPIC. No, I told you static linking के लिए एक AR command है. Have you used this AR command? आप नेक्स्ट टाइम से करके नहीं आओगे तो फिर से मार काटूंगा. ऐसे ही आपको करना पड़ेगा, नहीं तो कर नहीं रहे हो आप लोग. Okay, so I'll start. Please do it. This is nothing marking, nothing. By practicing, you can show that we know how to create a library. आप ऑपरेटिंग सिस्टम पढ़ लोगे, आपको पूछेगा लाइब्रेरी फाइल क्रिएट कीजिए, आप बोलोगे नहीं आता है. What's the meaning behind this? Are you getting my point? और आपका सी का जो पढ़ते हैं उनको भी तो हेडर फाइल बनाना आता है. आप क्या फिर ज्यादा सीखे? समझ रहे हो ना? नेक्स्ट टाइम से जो सीखेगा और 500 को बताया कि ऐसे किया, सो दैट अदर कैन ऑल्सो लर्न. एक तो एटलीस्ट कोई करना चाहिए. आप क्या इतने बुरे हो? ठीक है ना? नेक्स्ट टाइम से करोगे प्लीज. somebody has to be do how to create a static library, how to create a dynamic library. जब डायनेमिक लाइब्रेरी क्रिएट करोगे उस टाइम पे व्हाट इज द रिक्वायरमेंट? द बेसिक रिक्वायरमेंट इज दैट the dynamic library has to be stored at a certain place. Why it is like this? Because every program throughout the system can able to access your library. Are you getting my point? Like a printf, the printf has to be stored in a common place so that everybody can access. In the same manner here also, when you create a dynamic library, this dynamic library file has to be stored at a common place. But a static library may not be necessary. I'll use it inside my program, then I can do this. So that's why while you are doing the static dynamic library, you have to go through this. So now today's last class we have studied that what are the different translation or binding methods. What is the first method we have studied? The compile time binding. What is the compile time binding? Says that at the very beginning, the compiler has to know what is the memory addresses where the free spaces are available, so that during the compilation, every line of code has to be given with that particular addresses. And in case of a compile time binding, only one program has to be run at a time or stored inside the memory, so that it will be more beneficial. If more than one program has to be stored inside the memory at a time, then your compile time binding may not work proper manner. Another disadvantage of the compile time binding is that the moment you load the program inside the memory, there is no way to change the location of that instruction. If the instruction has once loaded in 15, throughout the execution of the program, you cannot change it. But nowadays, whatever the system you are using, now if your A plus B is stored in a 10th location, after a few minutes, the same programs, same line will be stored in a different location. As somebody has asked in the last class, if what happens if the whole memory gets filled up? Then what you are using? Swap area. Yes. What the swap area work says that the existing program which is currently present inside the memory, that has to be moved to the swap area and a new programs will become. Now the question comes, when a new program comes, whatever the existing program currently running, that is move out. Suppose that program was currently present in the 14th location. Okay. After some time, that program has to run. Then where it will come?
After the execution of the write-out process, then it will
come where it will come? To the 14 or to a different location?
It depends if the 14 is free.
Yes. If that 14 space is free, then it will come to the 14. If it is not free, it will come to the different location. But if it is come to the different location, previously 14, now it is something, then that cannot be a compile time binding. Are you getting my point? Partially execute हुआ था, फिर आप बाहर निकाल दिए, फिर उसको बोले कि आप अंदर आ जाओ. अगर वो अंदर आता है, उसी चेयर में ही बैठेगा. If you are giving some other chair, then that is not a compile time binding. Then these are the problems. Then what is the next issue comes? The next one is called load time binding. I'll give you an example where you can understand what is a load time binding. Suppose now 5 persons are joined in offline. Yes, offline students. Can your hostel people will give you the detail about in which room you will stay when you are in the home? समझ पा रहे हो? 5% has applied for the offline, and you want to come here, stay in the hostel, and you say that sir, हम लोग 5 आदमी एक ही साथ एक जगह से आ रहे हैं, हमको 5 contiguous room दीजिए. So what this hostel people told, no, I cannot give you now, but I am giving you this guarantee that when you will come, I will give you this 5 rooms continuous. But which room I cannot give you. Are you getting my point? Previously he told, I will give you these rooms. That is the compile time binding. You know that if these are the rooms, this 5% is going to be stored. But now in the load time binding, what is saying? The hostel person told that I cannot give you the room number at the very beginning. Unless until you come to front of this hostel, I cannot give you the number. But what you told, this is my 5 lines. This 5 lines, I need continuous 5 lines. That also you told. Then what kind of address you will prepare when you make a load time binding? Are you getting my point? What kind of address you have to prepare so that you can make a load time binding? So you can think of that, sir, I prepare a executable file. Let's take it is become a.out. And my program is the memory is this. This is my RAM. And this load time binding basically says that when you prepare this instruction, the instruction you can number as a 0, 1, 2, 3 like this. Then what is the meaning? I give an address as per my own choice. 0, 1, 2, 3. This is a normal address. Koi bhi bol payega. But when you come to the hostel is giving a base address called as 100. What is this meaning of this 100? Since your number becomes 0 in this line, then you will be stored in the 100th address. Since your address here it is a 1, then it will be stored in the 100 ones address. Then what it does? Previously you don't know the hard coded address. You know some kind of relative address.
Array wala.
Relative addresses. The moment you come to the hostel, he is giving you a base address. Then what you did? This base address, this particular relative address, when you add it, then you can get an exact location or not. Difference समझ पाए? Compile time binding में पहले क्या बोल रहा था? वो पूरा fixed address दे रहा था. 11, 12, 13, 14 ऐसे दे रहा था. Now he's saying, no, I don't know these things. I just know that I have to stay this 4 persons at the continuous rooms. So I give an address as a 0, 1, 2, 3. But when you come to the department or come to the hostel people may sometimes give 100, may sometimes give 200, may sometimes give it 250. So depending upon my base address, depending upon my relative address, if you combine it, then you can get the actual address or not. Understood क्या difference है दोनों के बीच में? So यहाँ क्या फायदा होगा? You don't have to know earlier where you are going to store. But when you come here, at least you will say that this is the room you are going to store. Once you store in that room, then no change, nothing. So who is giving this? During the load time. During the load time, the loader assign a base address. Assign a base address. Yes, once you get this base address, then what you have to do? The program a.out is generate an address named as called as a relocatable address. Relocatable address. Once this address is generated, then this base address will be combined here. Hopefully you remember in the COA, there is a register called as a base register. What is it? COA mein?
Yes,
एक register is a base register. That base register will keep this base address. Once you get this base address, this relocatable address will be generate the actual physical address. समझ पा रहे हो क्या किया? Oh, so you generate a relocatable address, and depending upon my base address, the physical address gets changed. If it is 100, then 100, 101, 102. If it is 250, 250, 251, 52, 53. Then what's the benefit? I don't have to know. The compiler should not know where the location is free. The hostel person has to know where the location is free when the person has come and do it. That's why the name is called as a load time binding. Means during the loading of the program, that time he has given a base address. With this base address, the relocatable address gets added and create a physical address. Along with this relocatable address also added a new register called as a limit register. And this limit register is used for the protection purpose. And what is the protection here? He is saying, suppose my program size is 10 size program. Then what my limit register will keep? The limit register will keep 10. What is do? You generate a relocatable address. What is the relocatable address numbers? 0 to 9. Once the address is coming, this has to be compared with this limit register. If my relocatable address is less than this limit register, then it will come here, S. If it is greater, then no, and it will be aborted. If it is S, then again it will be combined with whom? The base register. And after this base register, it generates a physical address. समझ पाए दोनों में बीच में क्या difference है? First में क्या था, next में क्या था? This is your RAM. In the first case, we are not using any limit register. Directly address generated, come address, add with the base address and come here. But here he is putting one extra restriction. What is that? Whether my address, relocatable address, is less than this limit or not. If it is less than this limit, means it is a valid address. If it is a valid relocatable address, then come here, execute. So what is the meant for this purpose? Providing the protection or not, so that you cannot go beyond your capacity. Suppose a program unknowingly generate an address which is beyond the range of the total number of lines. Then can you able to execute, or you don't have to execute? Don't have to execute. Got it point? This is ask question.
सर ये लिमिट 10 है और ये 9 है, तो सर 10 भी तो ले सकता है ना?
Now 10 number of lines. Think that it is a 10 number of lines. If my relocatable address starts from 0 to 9, it is always less than 10 or not. Yes or no?
सर वो equal to नहीं होगा? Less than equal to?
नहीं होगा, क्योंकि how many number of lines are present?
10
lines. Numbering starts from 0 means maximum address should be what? 9. Then how it is equal to 10? Got it?
सर वो लास्ट वाला से कंपेयर कर रहा है.
Last वाला से. Okay, so this is called as tell me.
Sir, can you please repeat who generates relocatable address?
Yes. When you are compiling, during the compilation, it will be generate a relocatable address. Are you getting my point? During the compilation, it will be generate a relocatable address. Once the address will be generated, and this address is not known to anybody, it is only known to the program. Why? Because if there is a 10 lines, he has just given a base address as a 0, 1, 2, 3, 9. Is it necessary to known to anybody? No. Only whom to known? Only it is known to your operating system that how many maximum number of lines can be present inside your program. That is necessary or not?
Sir, so how this value determines the limit things? How will get to know that?
That's something. Suppose you go for the address bus of a 32-bit. What is the machine's limit for each process? 2 to the power 32. Who knows? Operating system knows. Why he knows? Because he knows that your processor is a 32-bit. He cannot go beyond this. क्यों 32-bit में क्यों 4GB है? कोई बोल पाओगे?
Yes, sir.
32-bit जब machine होता है, what is the 32-bit machine?
2 to the power 32.
No. What is the 32-bit machine meaning?
मतलब एक ऑपरेशन पे वो 32 बिट एड्रेस कर सकता है मतलब.
सर वो 4
Sir, one instruction is 32 bits long.
Yes, वो
No.
32 बिट्स.
The address bus is usually 32-bit.
हाँ मतलब 32.
अगर वही समझ रहे हो तो आप करेक्ट बोल रहे. एड्रेस बस 32-bit है. एड्रेस बस क्या है? बस क्या है?
सर जिससे कनेक्शन
Address
वो
bus.
बस मतलब लाइन. ये कितना लाइन का है?
डेटा और एड्रेस.
लाइन का. So 8-bit bus. This is a 8-bit bus. In each bit, either 0 or 1 is coming. Then 8-bit में कितना एड्रेस जाता है? 0000 0001 ऐसे होके 1111. So total कितना जा पाएगा? 2 to the power 8. Similarly बोलिए, आप CPU के पास एक पिन है जो कि 32-bit पिन वाला है. So CPU can generated maximum कितना एड्रेस कर पाएगा? 32. If 32 का जनरेट करेगा, with this 32-bit, what is the range of addresses? 0 to 2 to the power 32 minus 1.
32. Yes.
Got my point or not? Means if I am writing a program and each program line will be address, your CPU can represented each line by how many bits? 32 bits. So total kitna line वो maximum represent कर पाएगा? That's why it is means operating
2 to the power 31 32.
2 to the power 32 minus 1. वो operating system जानता है. So that is my limit. समझ में आ गया? Limit उसको पता है. And based on this you have designed it. So if it is cross, it is not a valid program. If it is beyond, it is a valid program. Once you get a valid relocatable addresses, join with a base addresses, then it will get it. Yes. फिर भी क्या
और एक चीज है
हाँ
सर, जब हम लोग सी में एरे करते हैं तो वो अगर आउट ऑफ बाउंड नहीं देता है तो इसमें तब लिमिट क्रॉस हो जाता है ना कई बार।
कहां पर? नो 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 नो, अरे का बात तो थोड़ी देर बाद पेजिंग में बताऊंगा। अरे में लिंक कट नहीं हो जाता। अरे का बात पेजिंग के टाइम पर बताऊं। हाँ, वन एस क्वेश्चन। वेट oh very nice. Very nice question. Whatever the address, whatever, this is my a.out program. This a.out program has a 10 lines. I generate a address. कुछ address यहाँ लिखा हूँ. What is the address? 000 001 010 like this 111. कितना bit का address है? 3 bit का. Yes. How many number of lines maximum present in my executable file? 8 lines. 8. But when this line is coming, is it exactly stored in the 001 or something else? Now can you tell me, is it an actual address or a virtual address?
Virtual.
Directly to the virtual. समझ पाए? जो वो उनका क्वेश्चन था जब एड्रेस स्पेस में हम पढ़ रहे थे, अगर याद होगा, this is my address space.
हाँ तो सेम हो जाता है दोनों का. 0
से 2 to the power 32 minus 1. When you make a fork का भी वही है. And during this time, if there is a variable a present, a is also present here. दोनों का address same है.
Yes.
Means what? These two programs A is stored in one location, which is currently it's a virtual address. But when it is actually loaded, A may be loaded to 20 location, this A may be loaded to 45 location. So this 45 and 20 becomes a physical address or not? And how it is changing? Now you can say, एक 10 लाइन वाला एक आदमी आया और एक ग्रुप आए, उनको बोला जाए कि आप 10 लाइन 100 वाला रूम के पास जाके रहिए. So another 10 लाइन का भी एक ग्रुप आए, उनको बोल दिया कि आप जाके कैपिटन का 20 नंबर रूम के पास रहिए. He is telling like this or not? Hostel people, he is telling like this. Then what is? When you come to the hostel, your number, your group number is 01, 2, 3, 4, 5. Another groups also numbering as a 01, 2, 3, 4, 5. But when it is come to the hostel, somebody has get a KP5 ka 20, somebody is getting a KP7 ka 100 wala room. Then 100 वाला जो रूम है वो है एक्चुअल एड्रेस और द फिजिकल एड्रेस. 012 जो जनरेट हुआ था ये लॉजिकल एड्रेस. समझ में आ गया दोनों का? अभी भी प्रॉब्लम है. व्हाट इज द प्रॉब्लम? Once the base address gets generated and your relocatable address will be added with the base address, then it will be stored in one location. The same problem comes if your memory get filled up, you will be out and again you have to join. You have to join in the same location. But what I need, if I'm using a larger number of programs, more number of programs at a time, you cannot fix the room for each individual. सुनो, एक आपका क्लास में और क्लास में बोला था कि suppose you have created a big hotel. If inside the big hotel very few people are coming, then if it's a minister comes, always you can fix a room. A minister आप आओगे तो 15 नंबर रूम में रहोगे. Assume it is a big hotel and it is always crowded. Can this hotel manager will be allow a fixed room to a minister? नहीं सर, आप जब आएंगे हम बोलेंगे. then इसका सिचुएशन नहीं है. This is a crowded room. Thousands of programs are running. If you fix a location, nobody likes. आप जब बाहर जाओगे फिर आओगे, आप ढूंढोगे वही रूम में रहूंगा और कोई ऑक्युपाई कर लिया होगा क्योंकि crowded है. This more number of programs are running. Yes or no? Then what you need? Still, it is better than the compile time binding, this load time binding, because it is giving at least a different location when you are loaded. but still our requirement does not satisfy. That's why they are going for a next one that is called as execution time.
सर एक डाउट है
हाँ बोलिए.
सर, कंपाइल टाइम बाउंडिंग में मतलब वर्चुअल में जो मेमोरी है मतलब जो एड्रेस है वो भी रैम पे उस सेम एड्रेस पे रहेगा ना?
No,
सेम कॉन्सेप्ट है.
no, load time binding में या compile time binding
कंपाइल टाइम बाइंडिंग पे
same address में रहेगा. Some address में रहेगा.
वर्चुअल में भी जो एड्रेस है वो रैम पे
Yes,
सेम
yes.
एड्रेस है.
He is saying his question is that in case of compile time binding, can your virtual address is equal to the actual address? कंफ्यूज मत हुई है. इन ए कंपाइल टाइम बाइंडिंग, क्योंकि मैं खड़ा नहीं हो पा रहा तो इसलिए आपको सही तरह से देख के पूछ नहीं पा रहा हूँ. हाँ प्लीज कोऑपरेट. इन ए कंपाइल टाइम बाइंडिंग, कैन योर वर्चुअल एड्रेस विल बी सेम एज द फिजिकल एड्रेस और डिफरेंट? सेम.
सेम हुआ तो
टाइम बाइंडिंग
हाँ
हार्ड कोडेड ना, जो जनरेट हुआ होगा लॉजिकल एड्रेस वही है फिजिकल एड्रेस की नहीं, लेकिन इसमें चेंज हो गया. बट फिर भी once it is stored you cannot change it. So next आया execution time binding. और the execution
वो तो सेम होगा. तो जो आपने वो फोर्क का एग्जांपल दिया, दो सेपरेट ए का सेम प्लेस पे मतलब सेम एड्रेस है, तो वो दो एड्रेस दो ए तो कंपाइल टाइम बाइंडिंग पे रैम पे स्टोर नहीं हो पाएगा ना.
very simple. If you are doing this fork in this compile time binding, then fork will not work there. Finish that.
ओके.
He is
सर
saying
वहां पे फिर वो
you do
तो
it-
ये दूसरा स्टोर होगा.
fork in a compile time binding, can it will work out? नहीं हो पाएगा, क्योंकि पहले से ही हम पढ़ लिए कि in case of compile time binding mostly suitable for the monoprogramming. Monoprogramming मतलब at a time one program ही execute हो पाएगा. What is the question of fork? समझ पाए? Answer? हाँ, next question. No question. Fine. So what is the executable time binding says that during the execution, the instruction can move from one memory location to another. Means there is no fix it. During the execution time, it will decide, your operating system decide where to give. This particular line has to be stored in which location. After some time, this line will become from that place and store it in a different location. Means there is a movement of a single instruction from one place to another place during the runtime, which is currently going. Means whatever the system we have, that is basically using a which kind of binding? Execution time. Yes. And now the whole 10 or 12 classes further is related to this execution time. समझ में आया? Yes. Execution क्या है? Then loading क्या है? Compile time. ये बहुत important है. सब समझ में आया? अभी पढ़ते. Then what are the different kinds of systems? The types of systems. So first one is called as a monoprogramming system. Programming system, and another one is called as a multi-programming system. Yes, what this monoprogramming system says that last class पढ़ चुके हैं और ज़्यादा नहीं पढ़ेंगे इसके बारे में because we don't require now. In a single RAM, only one part will become OS and the rest of the part will be utilized by your application.
No preemption.
No preemption, nothing. But the last class also he added one thing, that if my program size will be bigger than this, to help him, I use a one more small program called as yes. इसका बारे में ज़्यादा नहीं पढ़ेंगे. And tell me, monoprogramming is suitable for which kind of binding? Quick answer.
Compile.
This monoprogramming is using a compile time. Yes. Then come to multi-program. So what is a multi-programming system? Now actual work starts. What do you mean by multi-programming? Guess.
preemption allowed,
More
context
than
switching.
one program at a time present in the memory. Very simple definition. More than one program at a time present in a memory. Very simple. हाँ? एक टाइम पे 4-5 प्रोग्राम एक साथ रैम में रह पाएगा. अगर रहेगा कैसे रहेंगे? Then this, if more than one program will be stay, then there is a different allocation techniques for this allocation techniques. What is? I'll tell you. Then you can guess. कितना रहेंगे? 4-5 आदमी एक साथ रहेंगे. वो बोल रहे हैं. Yes. एक आदमी के पूरा फैमिली के साथ आए हैं. सोच लीजिए 5 प्रोग्राम मतलब 5 आदमी. All programs can stay at a time inside the memory, but हर एक जो आदमी उनका फैमिली लेकर आए. ठीक है ना? होटल में रहेंगे. सो कैसे रह पाएंगे? You can say the allocation scheme कैसे करेगा hostel manager? One can say it is a contiguous allocation. Or non-contiguous allocation. What does it mean? You can guess. So that हम पूरा फ्लो में जाएंगे तो पहले मेमोरी मैनेजमेंट शुरू होगा तो आप बता पाओगे लास्ट क्या है. क्या है? अभी 5 आदमी आ गए फैमिली के साथ. वो बोलेंगे कि होटल में रहेंगे. तो होटल मैनेजर 2 टेक्निक बोला. एक बोला कि कॉन्टिग्युअस एलोकेशन. कॉन्टिग्युअस एलोकेशन क्या हो सकता है? बोलिए.
अरे
At a single chunk of memory, the whole program is going to be stored. Means what? Means what? If you go for this one, this is my memory. The whole P1 stored here, whole P2 stored here, whole P3 stored here. ऐसे नहीं कि उनका पापा जाके और कहीं पर रहेंगे और जाके उनका बेटी जाके और कहां पर रहेगा और बेटा जाके और कहां पर रहेगा. No, all these 5 persons belongs to this P1 family. Has to be continuously stay in the memory. Then it is called as a contiguous memory. समझ में आ गया? Very easy है. तो क्या बोलता है? The whole program has to be stored in a single chunk of memory. Just write it. The whole program, because कभी-कभी theory में लिखना पड़ेगा ना, इसलिए बोल रहा हूँ. The whole program has to be stored in a single chunk of memory. Obviously, other one आप बोल पाओगे. Then what is the other one? Non-contiguous. What is the non-contiguous? Let's take a P1 has a family member L1, L2, L3. P2 has a family member L4, L6, like this. Then if it is my memory, then what is saying? L1 will be stay here. L2 will be stay here. L3 will be stay here. L4 will be stay here. Like this, they will be stored. Then what happens here? Even if this L1, L2, L3 are the 3 instruction belongs to P1, but in a single chunk of memory, they have not stored. L is stored here. L2 is stored here. So, sorry, I've written T. T1 is stored here. T2 is stored here. T3 is stored here. Similarly, for T4 and T5, this is stored here and this is stored here. Means that is not necessary that they have to store in a single. समझ में आ गया? Yes, दोनों तरीका हो सकता है. Then you'll go for what? How this contiguous allocation can be managed. So we'll study now the contiguous memory allocation. Contiguous memory allocation technique. हाँ, बोलिए.
सर इन contiguous in sir load time binding and execution time binding sir उसमें overlay use होता है sir?
Usually in the compile time binding overlay is used. Since compile time is also somehow following this load time binding, you can use a overlay. But one question you have not asked, very important question, that if sir this compile time binding is saying that it is hard coded, if my overlay is taking 1 to 10 line, fix it in the first 10 places, and 11 to 20 lines has to be also placed in 1 to 10, no? वो क्वेश्चन कोई भी नहीं अभी तक नहीं पूछे हैं आप लोग, समझ पा रहे हो
सर
क्या है? If my total number of lines is 1 to 20, प्रोग्राम का लाइन ए डॉट आउट का, कल मैं बता दिया था कि ओएस यहां पर है एंड 11 से 20 तक खाली है, यस, एंड 11 से 20 नहीं है, 25 तक, and in this 21 to 25 I kept this overlay. How this overlay can manage this 20 line program?
सर चंक,
आप बोले चंक, वेरी नाइस. इफ इट इज बिकम चंक, चंक का लाइन क्या था? 1 to 10 लाया, सॉरी 11 to क्या लाया? 11 to और 11 to 20, 11 to 20 लाया, and he can fix it here. But after this program gets over, this is from the 21 to 30. वो कैसे करेगा? Because if it is a hard coded, you are saying this 21 to 30 has to be placed in the 21 to 30 only. But there is no 21 to 30.
प्रोग्रामर को पहले से पता होना पड़ेगा कि ओवरले कहाँ पे है.
Yes, the overlay somehow he has to make a modification. Why? Because 21 to 30 has to be hard coded, means it has to be placed in 21 to 30. But there is no such location called as a 21 to 30. Even if 21 to 25 is there, but 21 to 25 is occupied by the overlay itself. There is no 25 to 30 also. Then 11 to 20 has no issue. But when 21 to 30 has come, there is a big issue. Then
ये नहीं कर सकता है.
somehow modify. And he is making a mapping. The 21 जाएगा 11 के पास, 22 जाएगा 12 के पास. He has to be internally do some mapping. नहीं हो पाएगा कभी?
नहीं सर.
are you getting my question or not? Yes, क्योंकि आप अगर बोल रहे हो कि हार्ड कोडेड का लॉजिकल एड्रेस इज सेम एज ए फिजिकल एड्रेस, हमारा फिजिकल एड्रेस में 21 to 30 तो नहीं है, एंड आप बोल दिए कि ये वाला प्रोग्राम आपका कंपाइल टाइम बाइंडिंग फॉलो करता है, हाउ इट विल डू इट? इट कैन नॉट. समझ में आया? देन व्हाट ही हैज टू डू? फॉर 10 to 20 इट्स ओके. From 21 to 30 somehow this overlay has to be modified. That 21 जाके रहेगा 11 पे, 22 जाके रहेगा 12 पे, like this. But it purely hard coded यहाँ पर नहीं कर. Yes, understood? हाँ, question.
सर प्रोग्राम में तो 1 से भी जा सकता है एड्रेस, तब वो ओएस के साथ कॉन्फ्लिक्ट करेगा.
हाँ,
तब भी इसको थोड़ा बढ़ाना होगा बेस जैसा.
ये क्यों नहीं करेगा? From 1 to 10 OS is not given to anybody when you are compiler prepared. That you have to know everything. Yes, you have to know these things always. कभी भी नहीं कर. Now come to the contiguous allocation. What the contiguous allocation say? That a single chunk of memory has to be placed there. Under contiguous allocation there are two techniques. One is called as a fixed partitioning.
Sir,
हाँ सुन रहा हूँ
सर. यहाँ पे जो सर 11 से 20 है सर, वो तो सर मतलब कंपाइल टाइम बाइंडिंग में मतलब पता है ओएस को कि मतलब 11 से 20 खाली है.
हाँ,
तो सर फिर जब 21 से, उसको तो ये भी पता है कि 20 से 21 मतलब फील्ड अप है, मतलब
रिजर्व है. हाँ,
तो सर वो 20 के बाद सर फिर 11 क्यों नहीं लिखेगा सर?
यस, बोलो. बिकॉज यू आर डिजाइनिंग ए प्रोग्राम. अगर 21 से आपका 11 लिख दिया, वो बोल रहे हैं कि व्हाई योर कंपाइलर विल नॉट राइट 11, 12, 13, 14 लाइक दिस. वेरी नाइस क्वेश्चन वो पूछे. वो बोले कि 11 to 20, 11 to 20 लिखिए, जो 21 to 30 वो भी 11 to 20 एड्रेस दीजिए. बहुत अच्छी तरह से बोले, समझ पा रहे हो ना? इसका एड्रेस 11 है, इसका भी एड्रेस 11 है, इसका एड्रेस 12 है, इसका भी एड्रेस 12 है. फिर समझ में कैसा आएगा? when your OS, very nice, when your S fetch this 11, is there any duplicate copy or single copy? No sir, duplicate copy, single copy. क्यों single copy? This part is exactly stored in this part. इस टाइम पे 11 है नहीं है, so there is no. This is also an approach you can follow. क्या बोल रहे हैं? फिर से बोल रहा हूं. फर्स्ट पार्ट इज 11 to 20. नेक्स्ट पार्ट इज ऑल्सो फ्रॉम 11 to 20. मतलब क्या बोल रहे हैं, सपोज 4 लाइन का ही मेमोरी है, तो क्या करेगा वो कंपाइलर 1 2 3 4 1 2 3 4 ऐसे बना देगा. बट इनसाइड माय मेमोरी this 1 2 3 4 will be fast stored. That time can your this 1 2 3 4 will be stored? No. Even my OS is demanding for one. Which one he is then demanding? This particular. But one point you can argue now, sir, this one से अगर एक go to statement लिखा गया है
तब तो हो गया.
फंस जाओगे. क्यों? If this go to statement is pointing to this line, then क्या लिखा होगा? यहाँ पर भी go to one लिखा होगा. If it is writing a go to one, what this compiler will be expecting, what the OS will be expecting? Madam, what this OS will be expecting? OS expect that वही लाइन को फिर से और कॉल करना है कि नहीं? तो क्या करेगा? वन लाइन पे ही वो घूमता रहेगा. So many issues will come when you use it.
सर एक सोल्यूशन कर सकते हैं इसके लिए.
No, there will be many solutions you think of, but I am saying there will be a different kind of issue comes even if you use a overlay. Accepted or not? Yes.
Sir.
Very nice point. Thanks to you, those who told that repeatedly 1 2 3 4 1 2 3 4. Now go to is will not work there. Okay. क्या होगा? हाँ no overlay is still there in the 21 to 21. अगर overlay को खाली कर देंगे फिर से उसको क्यों लोड करेगा? अगर आप बोल रहे हो कि अभी के लिए आप इसको हटा दीजिए, देन उसको कौन फिर लोड करेगा? Yes, so that's why what they're saying, the overlay has a fixed place to keep there. Don't move this overlay. Okay, that is the first. So obviously क्या है? दो टेक्निक आया. There is a multi-programming में either it is a contiguous allocation or it is a non-contiguous allocation. Contiguous allocation में पूरा रखोगे, एक प्रोग्राम को एक ही प्लेस में रखोगे. In non-contiguous allocation different. Now guess, nowadays it is a non-contiguous or contiguous?
सर दोनों ही होता है ना.
मोस्टली नॉन कॉन्टिग्यूअस. कॉन्टिग्यूअस में क्या प्रॉब्लम होगा?
वही सब कुछ लेफ्ट ओवर रह जाएगा.
अरे और लिंक लिस्ट में क्या डिफरेंस है? दैट इज द डिफरेंस बिटवीन दिस. अरे नीड्स ए कंटीन्यूअस 100 बाइट्स और 200 बाइट्स एंड ही सेज दैट माय एड्रेसेस शुड बी कंटीन्यूअस. यस, बट लिंक लिस्ट ही नीड्स दिस मच but separately. यहाँ 5 byte, वहाँ 5 byte, वहाँ 5 byte. This is the case or not? The non-contiguous says that you act like a linked list. This contiguous says that you act like a array. Now we'll study how this array works here or contiguous location are. Madam, another 10 to 15 minutes. Yes. Then the contiguous allocation. The contiguous allocation में दो type का होता है. Fixed partitioning, variable partitioning. So first we'll start with fixed partition. So what is the fixed partitioning? Just see. The whole memory, now concentrate, some problem will come now. The numericals, please concentrate. In case of fixed partitioning, please, the whole memory will be divided into fixed size subparts. Means this you consider as 100 bytes, this you consider as 50 bytes, this is maybe a 200 bytes, this is maybe a 300, this may be 100. What he says, the whole RAM will be divided into fixed size pages or fixed size parts in case of fixed partitioning. Then what it does, how many parts you have? The whole RAM has 100, 300, 200 means it is coming 3 to 5, 5 to 7, 750. The total size is 750. Out of this, I divided this 750 into 5 parts. When a program comes P1, P2, P3, P4 like this, what it does, he says, if P1 is a 40 byte, 50 byte program, P2 is a 90 byte program, P3 is a 100 byte program, P4 is a 150 byte program. And how this fixed partitioning does? The fixed partitioning, what is saying? Initially divided, then it will search. This 50 byte will be fit to where? Where you can fit? सर कहीं पर भी सर यहाँ रख पाऊंगा, यहाँ रख पाऊंगा, यहाँ रख पाऊंगा, यहाँ रख पाऊंगा, because 50 will be fit everywhere. But if you go for 90 somewhere, if you go for 100 somewhere, means there must be some allocation policy will be required or not. Even if I divided this whole 750 rooms into 5 different fixed size rooms, but when the program is coming, where to fit into, that is your decision or not. That decision will be done by a allocation policy. What is the allocation policy? He is saying fast fit. Second one is called as a next fit. Third one is called as a best fit. Fourth one is called as a worst fit. Yes, ये क्या है? In contiguous allocation, there are two techniques. One is fixed partitioning and variable partitioning. Fixed partitioning, under the fixed partitioning, there are different schemes are there. Okay. So what is a fast fit? Guess. From the
100
wherever this
First
fit it. Then बोलिए fast fit में कहाँ पर allocate होगा? P1 allocate here. Where the P2 will be allocated? Guess.
200
Very nice. यहाँ पर allocate होगा. This P2. Yes, P3 कहाँ पर allocate होगा?
300
Yes, that is this P3 यहाँ पर. Then कहाँ पर allocate होगा?
cannot allocate.
Finding a problem. Yes,
सर
no.
इसमें तो स्पेस है ना, मतलब
If I make a fast
वही
fit,
दिक्कत है.
if I make a fast fit, in this fast fit, this 50 will be allocated here because he is saying wherever the fast availability is there, you give it. So here you give it 90, here you give it, then P3, here you give it, then for 150, you could not get it. That is the biggest problem or not? One problem.
सर P3 200 पे क्यों नहीं होगा? उधर तो और भी 110
ना फास्ट फिट बोलता है कि यहाँ से सर्च कीजिए कहां पर वो मिलता है.
पूरा
50 पे 90 ढूंढे, 50 पे नहीं हो पाएगा, 90 यहाँ हो पाएगा. Because a fixed partitioning, very nice point. In this fixed partitioning, in a single partitioning, only one program can be stored. समझ पाए? जो पार्टीशनिंग किए हैं, बड़ा रूम है, छोटा रूम है, बना दिया है होटल वाला, एक 100 साइज का रूम बनाया, एक 50 साइज का, 200 का, 300 का रूम बना दिया. एंड ही सेइंग जब लोग आएंगे मैं फास्ट फिट एलोकेशन करूंगा. सो एक 50 वाला लोग आया, उसको बोल दिया कि फास्ट रूम खाली है तो जाओ, चले जाओ. वो देखा कि 100 वाला रूम खाली है, रह जाओ. 90 is coming, 90 cannot be allocated here and allocated here. So like this, if you do it, even if my memories are available, still I could not allocate it. That is one way. Another interesting point he has observed, when P3 gets allocated it here, partially gets allocated. Yes, कितना बाइट फिर भी खाली है यहाँ पर? 200. So
वेस्ट हुआ है.
Which can be fitted. Now what is saying? In a single partition, after storing a program, whatever the part is left out, that cannot be used by any other program. And that issue is called as a internal fragmentation. Internal fragmentation means internally some fragment has created which is not occupied by anybody. समझ में आया क्या ऊपर है? Yes. So these are the different allocation policy. During this allocation policy, the problem, biggest problem comes as internal. समझ पाए? इंटरनल फ्रैगमेंटेशन क्या है? एक ही चंक में एक ही प्रोग्राम रह पाएगा. यू कैन नॉट फाइंड एनीथिंग विल बी लेफ्ट आउट. दैट विल बी डन. देन कोई बोल पाओगे बेस्ट फिट कहां कैसा लोकेट होगा? अगर सेम
इक्वल वाला लिखेगा, सबसे नियरेस्ट इक्वल.
कौन कौन कहां पर एलोकेट होगा? अगर बेस्ट फिट करते हैं तो
50 में P1
पर P2
पहला वाला
हियर कि नहीं? ए भी 100 है, ए भी 100 है. सो P2 हो पाएगा. P3
वो तो 200. नीचे वाला
एकदम लास्ट में.
हाँ.
P3 P4
200.
सो बेस्ट फिट थोड़ा बहुत अच्छा है कि नहीं? यस. नेक्स्ट फिट क्या है?
फर्स्ट के बाद
if last allocation has done here, your searching has to be done from that onwards. समझ पा रहे हो? नहीं समझ पाए. एक एग्जांपल दे रहा हूं, एक सोच रहा हूं P1 का 50 था, हाँ, देन P2 का 90 था, 90 था, P3 का था 40, यस 40 था, हाँ, इतना बस याद रख लीजिए। देन माय मेमोरी लोकेशंस आर लाइक दिस। फर्स्ट पार्टीशन कितना था बोलिए तो 100 का ना, 100 का था, फिर 50 का था, फिर नेक्स्ट वन इज 200, नेक्स्ट इज 300, नेक्स्ट इज 100। अभी बोलिए फर्स्ट फिट में कौन कहां पर एलोकेट होगा, कोई कंसेप्ट? P1,
P1
then
थर्ड
P2,
वाला,
करेक्ट,
पहला वाला, सेकंड
P3, वेरी नाइस। क्यों है? Because first bit says that you search from the beginning where it can be fit, but next bit क्या बोलता है? Last allocation wherever it has done from that onwards। अभी बोल पाओगे अगर it is a next fit what will happening? P1 कहां पे allocate होगा? यहाँ। P2 कहां पे allocate होगा बोलिए? P1 पहले यहाँ allocate हुआ, नहीं, ये सपोज नहीं है, शुरू किया हूं अभी। P1 50 है, कहां पे एलोकेट होगा? फर्स्ट पे, बिकॉज शुरू से करेगा। P1 हियर, P2 90 कहां पे एलोकेट होगा? यहां एलोकेट हुआ है, यहां से सर्चिंग शुरू करेगा, तो कहां एलोकेट होगा? यहां पर। P3 यहां पे, समझ पाए? प्रीवियस वन दिस में फर्स्ट बिट में ऑलवेज ही सर्चिंग फ्रॉम द बिगिनिंग, नेक्स्ट बिट में wherever the last allocation has done from that onwards। समझ पाए? आप कभी नहीं बोलोगे सर ए होने पर क्या पीछे आता है? आता है, रोटेट भी करता है। जैसे हम लोग कहां पे पढ़े थे रोटेशन?
सर्कुलर क्यू,
वो भी तो एक पढ़े थे, एक लास्ट टॉपिक में पढ़े थे इस टाइप का कुछ।
हैशिंग,
हाँ, हैशिंग में
मॉड वाला
पढ़े थे कि नहीं? हैशिंग में तो यहाँ आएगा, यहाँ आएगा, यहाँ आएगा, फिर वो ढूंढेगा कि कहां पर फिट हो रहा है। समझ पाए?
लीनियर वाला।
फर्स्ट फिट समझ गए, नेक्स्ट फिट समझ गए, बेस्ट फिट। ओस्ट फिट नहीं बताऊंगा। ओस्ट फिट क्या बोलता है? जो बड़ा रूम है वो पहले रहेगा। बेस्ट फिट क्या बोलता है? wherever it will be nearly fit there you can keep it। worst fit बोलता है कि wherever will be large space I will stay there। then worst fit में कौन पहले रहेगा बोलिए तो? इस लोकेशन पे worst fit in this scenario
300,
P1 कहां पर रहेगा? यहाँ।
300,
P2 कहां पर रहेगा? 200 पे। P3 जगह है, P3, P4
100।
समझ गया लोकेशन? तो क्या क्या सीखे हम सीखे कि रिकलेक्ट। हम पहले से सीखे क्या है कि मेमोरी मैनेजमेंट में काम क्या है, गोल क्या है, सो दैट यू कैन रिकलेक्ट। गोल क्या है? हाउ एफिशिएंटली डिस्ट्रीब्यूट द मेमोरी अमंग द प्रोसेसेस। फंक्शनलिटी क्या क्या होगा ना देख के पार्टिसिपेट कीजिए। हाँ, फंक्शनलिटी फ्री स्पेस मैनेजमेंट करेगा, व्हेनेवर रिक्वायर्ड मेमोरी विल बी गिवन टू द प्रोसेसेस एंड प्रोटेक्शन। यस, देन क्या हम पढ़े? वंस यू नो दिस थिंग्स, एग्जीक्यूशन फाइल कैसे जनरेट करेंगे? दो टाइप का है, विथ लिंकिंग, विदाउट लिंकिंग। विथ लिंकिंग में दो टाइप का है, स्टैटिक लिंकिंग, डायनामिक लिंकिंग। फिर है कि दो टाइप का सिस्टम है, टू टाइप्स ऑफ सिस्टम, मोनोप्रोग्रामिंग, multi-programming। Before that we also studied the different kind of translation, address translation। once your program gets ready, how it is mapped to the memory। so compile time, load time and execution time। execution time is the best one। then we studied two type का system होता है, monoprogramming, multi-programming। monoprogramming है one program will be executed at a time। multi-programming में more than one program will be stay in the memory at a time। if more than program will be stay at a time, they may stay at one place, each program has to be stay at one place, or they may be distributed at different places। then we are studying that contiguous, non-contiguous। contiguous में दो टेक्निक आता है, fixed partitioning, variable partitioning। what the fixed partitioning we have studied? the whole memory divided into fixed size। fixed size मतलब मत सोचिए कि each partition have a equal size, या नहीं है। the fixed partition मतलब the whole memory divided into different chunks of different size, and वो size कभी भी change नहीं होगा, वो फिक्स है। आप बोलोगे सर ऐसे क्यों बनाया है, आप बोलोगे ऐसे क्यों बनाया, क्यों इक्वल नहीं बना दिया? Yes, because when you run the program, हम लोग फर्स्ट सेमेस्टर में 2 साइज का प्रोग्राम है, डाटा स्ट्रक्चर में 10 साइज का प्रोग्राम है, और एक सेमेस्टर में बिगर साइज. देन इफ यू मेक ए इक्वल साइज, देन जो सी प्रोग्राम लिख रहा होगा, इवन इफ राइटिंग ओनली printf, he will take 100 bytes memory. We may not prefer now, so that's why he has make a different size, but it is a fix. देन क्या प्रॉब्लम आया यहाँ पर, पॉलिसी क्या क्या किया, नेक्स्ट फिट, फर्स्ट फिट, ओस्ट फिट, बेस्ट फिट. देन क्या प्रॉब्लम आया, वो जो बता रहे हैं लास्ट में, क्या प्रॉब्लम बता दीजिए, व्हाट इज द प्रॉब्लम इन केस ऑफ फिक्स पार्टीशन?
फ्रेगमेंटेशन.
अभी बताते थे.
फ्रेगमेंटेशन होता है.
in one partition, once a program gets stored, few parts will be left out, and that part is called as an internal fragmentation, and this internal fragmentation will be avoided in a variable. नेक्स्ट क्लास पढ़ेंगे पार्टीशन वेरिएबल. हाँ वही बोल रहा हूँ, इन केस ऑफ फिक्स पार्टीशनिंग यू कैन नॉट मैनेज, दैट इज एन इश्यू. दिस इश्यू विल बी मैनेज इन ए वेरिएबल साइज पार्टीशन, वो जो नेक्स्ट क्लास में. हाँ क्या क्या, हाँ 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 जैसा है. ऑब्वियसली यहाँ पर भी आएगा, यहाँ पर भी आएगा. If it is a discontinuous, suppose very nice, he is telling a nice question. If we know what is the disadvantage of linked list, बोलिए. डिसएडवांटेज ऑफ द लिंक लिस्ट,
एक्सेस नहीं होता है,
एक्स्ट्रा मेमोरी ऑक्यूपाई करता है, मत बोलिए वो वाला.
रैंडम एक्सेस नहीं होता है.
रैंडम एक्सेस नहीं होता है. वेरी नाइस, रैंडम एक्सेस नहीं होता है. यस, हियर आल्सो इफ इज अ नॉन कॉन्टिग्युअस एलोकेशन, one chunk is here, another chunk is here, another chunk is here, how I can move from the first location to the 10th location? There is some issue. That issue will be sorted out by a paging and segmentation. There are two techniques. Okay, so next class हम क्या पढ़ेंगे, वेरिएबल साइज पार्टीशन. और क्या आपको होमवर्क दिया हूं, स्टैटिक लाइब्रेरी, डायनेमिक लाइब्रेरी दोनों का. That's okay. So I'm stopping now. Huh? Yesterday absent means absent, और दो दिन day before yesterday का attendance नहीं दिया हूँ अभी तक.
I forgot to write it on the paper which you should.
But nobody has given me the paper. 22 का नहीं दिया हूँ. हाँ, ये आप लोग दिए थे ना. Ma'am, you can start your. My job is over. ये आप लोग का नहीं है. ये वाला
यहाँ पे कंटिन्यू करना है क्या?
ये भी लोग हैं.
Sir, they have the email, so I'm just editing my roll number.
Why not? Do edit and give me 22 थे, 23 करके भेजोगे? ठीक है ना?
चलिए
22 करके 23 करके भेजोगे. I am ending the Pankaj.